we're going to do a few more mixed examples here of determining the definite integral, which remember just gives us a value. So we're going to do the integral 0 to 3 of 3x squared plus 4x take 1 dx. Now usually before I start I like to just quickly do the integral, and I represent that with a big F here. So that would be 3x cubed over 3 plus 4x squared over 2 take 1x. So that would just be x cubed plus 2x squared take x. I usually just do this because then it's nice and tidy. So then what I can say is, well, that's just going to be big square bracket x cubed plus 2x squared take x between 0 and 3. So that means all I'm going to do is sub 0 and 3 into these equations. So 3 cubed plus 2 times 3 squared minus 3 take 0 cubed plus 2 times 0 squared take 0, 3 cubed, so 27 plus 18 take 3. Everything over here just becomes 0. So then what we've got is 27 plus 18 is going to give us, what's that, 55? 45. Take 3, it's 42. Okay, don't need square brackets anymore, so we just write 42. So that means that is my exact value for my definite integral of part A. Part B looks like it's going to be a lot yuckier, but of course, if I want to be able to derive this, the very first thing we're going to need to do is to get a integral function, but I can't do that until I integrate this when it looks like it's able to be integrated. And what that means is I've got to put this whole thing up to the top line. So my integral here, I'm just going to split my page a bit so you can see where the working is. So if I integrate this, I'm going to increase my power by 1, divide by my new power, divide by my derivative of my bracket. Now, of course, I don't need a plus c on the end of any of that because we are doing definite integrals. So I've got -1 over 4 2x plus 1 squared. And all I've done is just write these numbers, just tidy a few things up. Now, as before, I now open up a square bracket and I put my integral in that bracket. So I've got -1 for 2x plus 1 squared, and I'm doing this between 2 and 1. So -1 over 4 times 2 times 2 plus 1 squared take -1 over 4 2 times 1 plus 1 squared. As you can see, these can get pretty messy. So simplify the left one, -1 over, alright, let's do my bracket, 2 times 2 plus 1, that's going to be 4 times 5 squared, so that's going to be 100, minus -1 over 2 times 1 plus 1 squared, it's going to be 9, so 4 times 9 is going to give us 36. Okay, now these are obviously two very different denominators, but we could make them the same denominator. So how do we do that? Well, we make them common denominators out of 360. So that could get pretty confusing though. We could times them both there and make them by 3600. So that would mean I times the left side by 36, negative 36 over 3600. I times the right side by 100. So take a negative 100 over 3600. And now we've got the same denominator. So minus 36 take negative 100, which is minus 36 plus 100. So that is going to be 64 over 3600. Now, of course, that's quite the fraction. We could start trying to take that 64 and divide it by 2 a couple of times to see if we can simplify that down. So we could say, how many times can you divide that? Well, 64. You can divide that by 2. You can divide it again. Eventually what you'll get down to is that can simplify to 4 over 225. All right, so all we were really looking at there was let's practice the process. We started off with a nice simple polynomial. Then we started off with a power function that you had to convert into a negative power over here before you could even integrate it. But the general rule was just practicing integrating, putting it into our square brackets, and then substituting in the bounds there of our definite integral.